Hello everyone, welcome to our daily physics problem, day number 34. So today we have a people with two mass of m are climbing on the rope from both sides of a frictionless masses pulley with the same acceleration according to the rope. In here, the big M is bigger than the small m. Then at the beginning, two people are both a distance h from the pulley. What is the distance the person with mass big M traveled when the person with mass m reaches the pulley in time t? So when we mean the distance the person of mass m traveled, it means what is the final distance between the pulley with the person. So I want you to pause the video, try it on. After you try, come back to the video and show you how I did it. So welcome back guys. So first let's lay out all the forces here. First we have two tension force and two gravitational force. One is smaller, one is bigger. Then based on this situation, we also have acceleration according to the rope upward. We set it a prime. But that's the acceleration according to the rope. They're the same. But what is the acceleration according to the ground? Well, we know both have to be climbing upward in somehow or downward. So we defined acceleration of the first person according to the ground as a1 and the second one is a2. Then we can lay out the system equation based on the equilibrium force and Newton's second law. So T minus mg equal to m times a1. T minus mg, big mg, will be equal to big M times a2. I made a mistake here, it should be a big M. Then we know kinetic formula, 2/2 times a1 times t squared have to equal to h, which is the distance the first person traveled from his position to the pulley. A1 will be equal to 2h divided by t squared. Then we solve for the system equation above. We plug in t will be equal to mg plus ma1 minus mg will be equal to m times a2. Just plug into the second equation. Then m minus m times g will be equal to m times a2. Yeah, we need to fix this to the big letter m. So then minus a1 times m. Then we divide both sides by big M. So m minus m divided by big M times g equal to a2 minus m divided by m times a1. Then we know a2. We are solving for a2 equal to m minus m divided by m times g plus m divided by m times a1. Then a1 is equal to 2h divided by t squared. Let's just plug it in. So now we are solving the distance the second person traveled and the distance from its original pulley. So we can lay out the kinetic formula. 1/2 a2 t squared will be equal to, let's just plug in a2. We have this expression here. Just plug the a2 into the big H equation. Then times 2h divided by t squared will just cancel out with an h left. Then finally we also need to add minus an h, because remember we are finding the distance it traveled and also the original distance already from the pulley, which is h. So we need to minus that. So finally we got m minus m divided by m. We move 1/2 to the right. We have 1/2 gt squared plus m minus m divided by m times g times h. So we factor out m minus m divided by m. Then we find the absolute number of it, because we need to find the distance, not the displacement. And m is smaller than m, so it have to be m minus m, big m minus m. So that will be our final solution here.